Okay, integrated algebra. Um, you have a worksheet that has 6 problems on it, a new one that Mrs. Roberts is giving to you, and I'm going to go through with you on how to write the equations, and then you guys can solve for them. You can pause between each one and solve for it, and then go back if you'd like. Okay, so number 1 says a farm has chickens and cows. You ask the farmer how many chickens he has and how many cows he has. The farmer tells you he has 28 healthy animals and they have a total of 64 legs. How many of his animals are cows? Okay, so in order to do this problem, I need to define some variables. So I'm going to let my x, where did it go? X, and I want a bigger size. So I want X to equal chickens and Y to equal cows. Okay, so what do I know? So I know my first equation is that they have 28 healthy animals. So in order to find the total number of animals, I have to add the number of chickens and cows that I have. So my first equation should be X plus Y is equal to 28. Now, here's the part that on the ACTs they had some controversy because kids in the city weren't sure how many legs chickens have because chickens in the store usually come with 4 legs, and so they threw these problems out. But we're from rural Iowa and we know. So we know we have a total of 64 legs. So we're going to write an equation that has an equal to 64. And so we have the number of legs. Well, X represents chickens, and we know chickens have 2 legs for every chicken. So 2X plus, and cows have 4 legs for every cow. So 4Y better equal 64. So now you have your 2 equations and 2 unknowns, and you need to solve. My suggestion, I personally would get rid of the X's, make them be opposites of each other. And so you're going to multiply this top equation by -2. Okay? All right. So I'm going to let you go ahead and finish solving for that. So distribute all the way through, add the 2 equations together, solve for y. And that's all I really need to solve for because really the question was how many of his animals are cows. So really all you had to do is find the number of cows. So once you solve for y, you're going to be good. All right. So you can pause the video and finish problem 1 if you want. I'm going to go ahead and do problem 2. Andrew has a collection of soda bottles. Some of them are 12-ounce bottles, and the others are 16-ounce bottles. If the collection contains 20 bottles, which hold a combined 300 ounces, how many of the soda bottles are 12-ounce bottles? So just like before with the cows, I'm going to define my variables. I'm going to let X equal my 12-ounce bottles. And I'm going to let Y equal the 16-ounce bottles. Okay, so now I'm going to write my equation. The first one comes from the fact that I know that there are 20 bottles right here. 20 bottles. Okay, so I know that altogether X plus Y better equal 20 because there's only 20 bottles. And the next equation that I'm going to write about is the fact that I know that there are a total of 300 ounces. So I need to do something about my ounces. Okay, so I know for every X is a 12-ounce bottle. So for every X I have, I get 12 ounces. And for every Y, I have 16 ounces. And the total should be 300. So I hope you're getting an idea of how I'm getting these equations and how to write them from our word problem. So looking at these two problems, I need to get rid of one of my variables. And it's really honestly a toss-up about which one you want to get rid of, the X's or the Y's. I'm lazy a little bit and I want to get rid of the smallest one. So I'm going to get rid of these X's. So then you have to make it be opposite. So the opposite of 12 would be negative 12. So that means I need to multiply this top equation by negative 12. Okay. Then add the two equations together. And again, it's asked, oh, actually right here, maybe this will, how many of the soda bottles are 12-ounce bottles? So I really don't want to get rid of my 12-ounce bottles. So that's going to change what I do, actually. So then that means, so since I want to solve for Y, yeah, no, I'm still doing okay. Nope, I want to solve for Y, X. So I want to multiply this by negative 16 so that my Y's go away, and then I'm solving for X. So I changed my mind after I read what they're asking me for. So my goal is to get rid of these Y's. Make those Y's opposite. Okay? 3. Jack and Cameron are playing a game of paper football. By their rules, you can score a 5-point touchdown or a 7-point touchdown. In the game, there have been 13 touchdowns scored for a total of 71 points. How many of these touchdowns were 7-point touchdowns? Okay, so let's define our variables. So I'm going to let X equal, we have two kinds of things, two kinds of touchdowns. I'm going to let X equal the 5-point touchdowns. I'm going to let Y equal the 7-point touchdowns. Okay, now I'm going to write my equation. So the two pieces of information that I have are the fact that there's 13 touchdowns and then a total of 71 points. So those are going to include my two equations. So I know for the first equation that there's 13 touchdowns. The number of touchdowns for 5 points plus the number of touchdowns for the 7 points better equal 13. Second is the number of the points. So I get for X, it's 5 points for every X, and then 7 points for every Y, and that better equal 71 points. Now, how many of these were 7? So I want to end up with a Y, so that means I need to get rid of these X's right here. So I have to ask myself, what do I need to multiply this top equation by to get rid of the X's? And that's a negative 5. Okay. Then you're going to distribute, add down, and get rid of the Y's. Okay. So now we've got number 4. Abby has $400 and $5 bills and $20 bills. So really the 400 is the total amount. She has 38 bills. How many of them are 20? So this is kind of like it's kind of like all the other ones that we've been doing. So let's define my variable. So X is equal to, I just have to pick one. I think I'm going to do the $5 bills. The number of $5 bills. So it's not the amount, but this is the number of $5 bills. And y equals the number of $20 bills. So I know that there's 38 altogether. So the number of $5 bills plus the number of $20 bills better equal 38. And now the value, okay? So for every $5 bill, it's worth $5, duh, right? And every $20 bill is worth $20, at least for now. And that is equal to a total of, she said, $400. So now I have my two equations and two unknowns. And we want to know how many of them are 20. So we want to know the y's. So that means I need to get rid of my x's. So I'm going to get rid of my x's. That means I need to make these be opposites of each other. And so I'm going to multiply the top equation by -5. Okay. I'm going to let you finish out the problem. So you should know how to do this part of the math. 5. The sum of two numbers is 40 and their difference is 6.5. What is their product? So this answer we're going to do later. This is going to be the last thing we worry about. Okay, so that's not going to be part of the word problem. Not yet. So the first two things I need to know is the fact that I have two numbers that add up to, because sum means 40, that add up to 40, and then the same two numbers have a difference of 6.5. Okay, so now I need to write my equation. Okay, so x is the first number, and y is my second number, just so I don't get confused. So the first thing I know is the sum. So sum tells me to add. So my first number plus my second number better add up to be 40. Okay. Their difference means subtract. So x minus y is equal to 6.5. Now we're going to get a decimal as an answer, and that's okay because they subtracted to be 6.5. So one of them has to be a decimal. Now what's lovely about this is, if you notice, these are already opposites of each other. So it's ready for me to add down. Now once I get my x and y, I'm not finished because they want me to answer the question, what is their product? So that means product means that you're going to have to eventually, you're going to have to multiply the x and y, because that's what product means. You're going to have to multiply the x plus y when you get your answer. All right, last problem on this page. This year, Jake is 5 years older than his sister. 3 years ago, Jake was twice his sister's age. How old is Jake's sister now? This one's a little bit on the weird, tough side, just confusing. So, oops. Changed size on me there. All right. So I'm going to let x equal Jake's age now. And I'm going to let y equal sister's age now. Okay. So I know Jake is 5 years older than his sister. So I'm going to let x, that's Jake's age, is equal to 5 years older. 5 years older means that it's going to be plus. So 5 plus his sister's age. That means Jake's older. 5 years older than his sister. Okay. 3 years ago. Now, if Jake is x, 3 years ago, his age is x minus 3. I don't know why I put that in parentheses. X minus 3. Three years ago, Jake was twice. Twice means 2 times. 2 times his sister's age. But his sister's age 3 years ago. So how do I write Jake's sister's age 3 years ago? Well, if his sister's age is y, then it's going to be y minus 3. And that's my equation. Now this doesn't look like any of the other ones, and so it's a little bit more confusing. And we're not going to use elimination this time, because if you notice in this problem, they told me what x equals. So everywhere I see an x, I can put 5 plus y. So I see an x right here, and so that means I'm going to put 5 plus y in for x and do substitution and solve for y, because that's how old Jake's sister is now anyway. Okay? All right. Have a good day. Be good for Mrs. Roberts. And pause the video where you need to, rewind it where you need to, and good luck.